Hi there. I've been working on this project for a few days now, and I finally got it working, and I thought I'd put it on YouTube in case someone else wants to do something similar. I've got an Arduino Mega talking to an ESP8266 Wi-Fi module that's transmitting through my home Wi-Fi to the cloud, and then I'm using the Blynk app on my iPhone in order to control this LED and to monitor the temperature from this sensor. So here, I can turn that LED on and off from my phone, and this is the temperature that I'm getting from the sensor. If I grab the sensor, it's going to heat up a little bit. It's also, my app is also tracking Millis, or the time that the Arduino board has been powered up. So this is a pretty simple circuit. It's actually part of a bigger project that I'm working on, which utilizes a lot more of the Mega capabilities. But the big hurdle was getting the Wi-Fi working, and I got that all in place now with this circuit. So I thought I'd show how I did this. I will show how to program the ESP8266. I'll show how to program the Mega, the Arduino Mega, and I'll show how to set up the Blynk app in order to receive and send data. Alright, I'm going to go over the hardware that I used for this project. Starting with, this is a 9-volt power supply. This is certainly optional, you don't really need it. However, at the beginning of this video you saw I was running the Arduino Mega from the 9-volt supply. It's handy to have in certain circumstances, and they're easy to buy off of eBay or Amazon. This is a 3.3 volt power supply. That's necessary in some cases because the ESP8266 module runs on 3.3 volts, and so you need a 3.3 volt supply in order to run that in certain circuits. This is a USB to TTL converter. I also got this on Amazon, and it's needed in order to program the ESP8286 or 8266. This is a breakout board because the ESP module doesn't have pins that are convenient for a breadboard. So you can buy one of these breakout boards that makes it easier to plug into a breadboard. Other people use wires like this to connect the ESP module to the breadboard, but this is pretty convenient. And if you're ordering some of this other stuff, you might as well get one of these too. This is an adapter for the ESP. You'll see me using it later in the video. Basically, it converts 5 volts to 3.3 volts for the ESP, and it makes connection to the Arduino a little bit easier. This is optional. You can probably live without it, but again, it's a pretty cheap piece of hardware. If you're ordering something else, might as well get one of those as well. Going to need an LED. This is a 330 ohm resistor for the light. This is the temperature sensor that I'm using. It's a DS18B20 sensor, which is a digital output sensor, and I bought this from the web from SunFounder, and convenient little temperature sensor. Again, that's just an optional thing. I only used it just to demonstrate the fact that I'm able to read something from the Arduino board and send it to my iPhone. You might want to use some other kind of sensor, or just don't even bother with the sensor. This is the Arduino Mega that I'm using. It's actually not the Arduino brand, it's another product from Sunfounder. But any Arduino Mega copy board would be probably fine. Got a breadboard and some wires and two different types of USB cables. One has to go onto this device and one of them has to go into the Mega. So that's the hardware that I used. Just a little bit of information about this guy. For a while I was having trouble programming my ESP module, and on Amazon there were some comments from people saying that the chip on this was a knockoff chip and therefore it wasn't working. So for a long time I was worried that the problems that I was having was because this wasn't, you know, this wasn't a valid board to use to program the ESP module. I later found there were other problems that I had in my system, and really this thing worked. As far as I can tell, the counterfeit or the knockoff brands work fine for this converter. Also, I'm using the ESP, this 8266 module. It's, you know, kind of what's known as a ESP-01. That's because I use this because it's the cheapest one, and I really didn't need it to have a whole lot of inputs and outputs. I just need it to run my Wi-Fi. There are a lot of other ESP8266 modules out there like this one, and these would probably work, but it was really more than I needed. Also there's a lot more documentation out there and YouTube videos that show the ESP-01 style. So that's why I'm using the ESP-01 instead of one of the more complex versions of it. But you can probably use one of these modules for this project, but it wasn't what I needed, and I'm only going to show how to use this type of module in the video. Now we're going to be using this TTL or USB to TTL converter to program the ESP8266. One thing that you need to be careful of is the output voltage. There's a jumper here which allows you to select whether you want 5 volts or 3.3 volts, and since our 8286 uses 3.3 volts, put the jumper on the, well, I'll call that the right hand side. I suppose it depends on which way you're looking at it, but anyway, that's the 3.3 volt setting for the adapter. Okay, when you receive an ESP8266 module, it will have some AT command firmware installed on it. The problem is you don't know which version of the firmware is installed, and the version is important to the project that we're working on here. So I'm going to show how to check the version and install new firmware onto the 8266 module. So the first thing you need to do is go on the web, and Blynk is the company that makes the little app that's on the phone that controls the Arduino, and they have some pretty good advice on running an Arduino with an ESP8266 Wi-Fi with AT commands. The funny thing is, one of the first things they say is, this is not recommended for beginners. And I can attest to the fact that this took a while for me to figure out. But since I'm guiding you through it, have no fear, we should get through this okay. Click on this help topic. So they talk a little bit about connecting an Arduino board to an 8266 module. This is obviously not the Mega. We'll get back to this later. This isn't used to program the 8266. We'll work on that in a little bit. One thing that's helpful here in this page is that they explain that Blynk was tested with the following AT firmware versions. So blah 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 blah. Here's the latest one, and that's the one that we're going to install today. So we're going to get this AT version firmware installed on this little module here. Okay, so where do you get where do you get this firmware from? Well, I went to this website here. So now they say it's a little bit confusing because they say that the version is 1.54, but actually when you download it, you'll see that there's two numbers. One is this number and the other number is this number. A little bit confusing, but bear with me here. So click on the link. You'll save it in your whatever folder you're interested in. I already saved it, so I'm not going to click on that right now. But here's the folder. After you download it, this is what you get. Now this was really confusing to me for a little while because they give two versions of the firmware. One is this 32M, the other one's 8M, blah, blah, blah. And for a while, I was trying to figure out which one I should flash to my 8266. I never found a good explanation of what the two different versions are. If someone knows the difference, please post a remark in the comments section of this video. Anyway, what I ended up doing is I just kind of took a long shot and said, well, maybe this is the one that I want. And so eventually I used this one, and it worked. So feel free to use that firmware. Now that we have the firmware loaded on our machine, we need a program to flash to our 8266. The flasher that I used, I got from this website. Don't worry, it gives you this whoops message. Just download it anyway. And save as in a place that is convenient for you. I've already downloaded it, so I'm not going to click save here, but we'll see what it looks like in a second. So here's the file, the zip file. And here's the flasher firmware or software that we use to flash to the ESP8266. Now, just to let you know, in this zip folder, there's another version of the AT commands. This is not the one that you want, but what we want here is the flasher. So extract this from the zip folder. I've already done that. It's in my temp folder. And we'll see, where's my flasher? Okay, so here's the firmware that we're using to, or sorry, I keep saying firmware. Here's the little app that we use to flash to the 8266. Beware, there's other flasher apps like this one. They do very similar things. Ideally, they would do exactly the same thing. However, I will tell you, when I used this app to flash my 8266, it did not my 8266 looked like it was working, but when I tried running the Blynk program, for some reason it didn't work. When I used this app to flash my 8266, everything worked fine. So if you have any problems with your 8266 not working, I suggest that you use this this app because it worked for me. There are probably half a dozen or maybe more apps out there that try to make it easy for you to program the 8266, but this is the one that worked for me, so this is the one that I'm recommending, and that's the one that I just showed how to download. So I showed you how to download, or I showed you where to get the firmware. This is the flasher. That's what's going to flash to the 8266. And finally, what we're going to need is the Arduino software itself. The Arduino software lets you communicate with the 8266, and that's what we're going to use it for here. Here's the Arduino program. We're actually only going to use the serial monitor at this point just to talk to the 8266. So those are the three things you need in order to get yourself up and running. You need the flasher, you need the firmware, and you need Arduino software. All right, this is the circuit that we're going to use to flash the firmware to the ESP8266. So here's the ESP8266. This is a breadboard adapter, and this is the USB to TTL converter that we're going to use. So on the 8266, we go from RX to TX on the converter, and vice versa, we go from TX on the 8266 to RX on the converter. Ground gets connected to ground, ground gets connected to ground. This is a 3.3 volt supply that I will use in the circuit. We could use the 3.3 volts from the adapter. However, some people have said that that might not be sufficient to drive the 8266. So just to be sure, I use the my own 3.3 volt supply. Anyway, 3.3 volts goes to VCC on the 8266, and we connect 3.3 volts to the CHPD pin. GP2 is left open, RST is left open. When we're flashing to the 8266, GPIO 0 gets connected to ground. If we're running the 8266 in its normal operating mode, GPIO is left open. All right, let's connect the circuit. And voila, we are ready to flash our firmware. So what we have here is we've got Arduino IDE running. We've got our flash downloader up and running. Let's check and see what firmware I have on this device right now. So to do that, I'll go to Tools, Serial Monitor. We need to make sure that I'm on the right COM6. Now I just happen to know that COM6 is where my USB cable is connected. So this USB is connected to COM6. You can see that in my device manager, COM6. So if we unplug, so now I disconnected GPIO0. So when I most AT command firmwares run at 115200. So then I cycle the power again. Okay, I think we're technology, Wi-Fi connected, AT, capital AT, GMR. So you can see on this 8266, we're already running the current version. That's not surprising because I flashed this a couple days ago. But it doesn't hurt anything to flash it again, and so I'll show you how to do that. So GPI 0, connect it to 0 or to ground, and then cycle the power. Now we go to Flash Downloader. All right, we're going to be flashing on COM6. Don't bother changing anything of that. This is the bin file. I showed you where to download the current version of the AT commands. So I open that and then click download. So this takes a little while. It takes about a minute or so to transfer all the firmware over to the ESP8266. Okay, it's done. It always ends with this failed to leave flash mode. Don't worry about it. That's not a problem. All right, now just to double check to make sure everything worked okay, we will check our firmware version. So I'll disconnect GPI 0 and I will cycle the power. I'll go back to my serial monitor and cycle the power again. AT, if you just type AT, it should say OK. I got the OK. And if we type AT plus GMR, we'll see that we have the correct firmware version. Okay, we're actually done with this part of the circuit now, so I'll unplug from here. So now our Wi-Fi module, we've confirmed that it has the correct firmware installed, and now we'll start setting up the Arduino and the other components to make this circuit work. Alright, this is the circuit that we're going to set up with the Arduino Mega and the Wi-Fi module. This is the adapter that I mentioned earlier. So this Wi-Fi module is going to plug into this adapter, it's a convenient way to connect the module to the Arduino Mega. So here's the wiring. On our adapter, we want to connect VCC to, this is ground. Obviously it goes to ground. And VCC gets connected to 5 volts. We're not connecting to the 3.3 volts because this board converts 5 volts to 3.3, which is necessary for the Wi-Fi module. This is RX, and that gets connected to pin 18 on the Mega, which is the transmit line of the serial 1 port. This is a hardware serial line that's on the Arduino. TX from the adapter goes to RX1, which is pin number 19 on the Arduino. We're going to have this LED that turns on and off, so we're just kind of picked a digital line. Any digital line will be fine. I picked 40, so that line 40 goes to the anode, call that positive side of the LED, and then we go through a resistor to ground. On an Arduino Mega, these two pin sockets are ground, and these two pin sockets are 5 volts. They're exactly the same as these. So we'll also connect this DS18B20 temperature sensor. It's pretty simple. It has a VCC 5 volts and ground, and a data line, which will connect to pin number 38 on the Arduino. And that's pretty much all we have to do to set up this circuit. Okay, next we're going to work on Blynk. If you don't have Blynk on your phone already, it's pretty easy to find. You go to the App Store, Blynk, and you'll see the app pop up. They have iOS versions and Android versions. I already have mine installed, so I'm going to bring it up now. So when you first start up Blynk, you're going to be asked to start a new project. So we'll start a new project. We'll give it a name like LED underscore temp 3. So the device that we're going to be working with is a Arduino Mega. There we go. You had an option of using the 8266 as the device, but we're actually sending commands to our Mega. We're not trying to send commands to the 8266. We are using the 8266 as our communication device, but our commands are going to be going to and they're going to be coming from the Arduino Mega. So that's the device that you choose for this particular project. Connection type is Wi-Fi. You have some other options there, but Wi-Fi is good for what we're doing. So then we're going to create project. Now, when you first create a project, Blynk is going to send an authentication token to your email address. That's my email address there. And that token is what's used to allow communication between your device and your phone via the cloud. So let's start put in a few widgets. We're going to have a button. This is going to be the button that controls the LED. So let's call this button, call it LED. and we'll give it a red color because my LED is red. And return. The pin is going to be a virtual pin. It may not be obvious what virtual pin means yet. Or sorry, no, we're doing the LED. So we're going to use digital pin, and on my Arduino Mega, the LED is connected to pin 40, as you may recall from the circuit diagram that I set up. Say OK. And these buttons seem to work a little better if you have them on the switch. So that's our LED button. Say OK. Now we're going to set up a value display. And this value display is going to display the Millis output from the Arduino. Millis is like a little counter that just runs whenever the Arduino is powered up, and we're gonna just send that information to the phone. Not that it's useful, but it just shows how the communication works. So return, and this is where we put in a virtual. So they call it a virtual pin. I think it would be better to call it a variable, but you can think of it either as a virtual pin or a variable that is going to get updated by the Arduino Mega. Okay, so I set that to virtual pin 5, and you'll see how that gets coded into the Arduino Mega in a little bit. Say OK, and I'm going to add one more display for our temperature. We're going to make that a virtual pin, and we'll set that to virtual pin 6. Just because it sounds like a good number. We'll call this temp. And update it every second. Okay. All right, so now we've got an LED button. We've got a value button or field that's going to track the Millis. And we've got a value field that's going to track the temperature. And in a second, you will see that Blynk has sent an email to my inbox, and that email will contain this authentication token. And you'll see how that gets used in a minute. So anyway, Blynk is pretty much ready to receive data. Now all I have to do is set up my Arduino and power it up and have it communicate with this. So hold on. Okay, next we're going to start working on getting the firmware installed in the Mega. We'll start from the Blynk website. Go to Getting Started. We've already downloaded the Blynk app for our phone. We've already gotten the authentication token. It's already been sent to us. I'll show that in a second. Install the Blynk library. So this is the library that's needed for the Arduino IDE, and there's some very simple instructions on how to get the libraries installed. I'm not going to show that in detail. Here's the link for the Blynk libraries. So click on that, download it, follow these instructions, and you'll be ready to go with your Arduino code. One thing I will mention is that the installation of the libraries was a little bit different than what I was used to. Normally, when you open up Arduino, normally I would go to include a library and add a zip library,
but in this case it didn't work using add zip library. Follow these instructions in order to get the libraries and tools installed properly. Okay, so got Arduino up and running. And I'll assume that you have the libraries and tools installed. The next thing we're going to do is create first example of sketch. So Blynk has this very handy tool that writes most of the code for the Arduino. All you have to do is tell it which board you're using. Again, we aren't using the 8266 to drive this code. We're using a Mega 2560. And then our connection is an Arduino. It's an 8266 Wi-Fi shield. We are not using the Arduino Wi-Fi shield. We're using 8266 Wi-Fi shield. Okay, here's where it asks for the authentication token. So here is my email. This is the email that was created when I first started that project on my phone a few minutes ago. And this is the authentication code that was sent to me, and it allows for communication between my Arduino code and the Blynk app on my phone. So I copy that into memory and I place it here. And the example code that we're going to use is push data. And you can see here that the code has already been updated with the token that you're going to use. And pretty much this code is almost ready to go. We'll just copy and paste it. Oops. Copy. We're going to create this sketch. And one last thing we need to do in our code is we need to update the name of our network. For me, that's the name of my network and the password of my network. That's the password of my network. So now the code is ready to go.
So I'll come over here and plug in my Arduino. And we'll compile. Hopefully it compiles without any errors. And update that to our Arduino. You can see it's blinking there. All right, now we'll open up our serial monitor and see what we got. Okay, it's connected to Wi-Fi. We need one more thing. Ping! That's what we're looking for. You need to get that ping, and that means that it has pinged the cloud. I assume that's what it means. And it's gotten feedback. Okay, get our phone. Go to Blynk, our Blynk app. This is the display that we created. Press play. There's a little play button up there. And you can see Millis is updating. And we should be able to make our LED turn on and off. Look at that. Temperature is not updating yet. That's because I haven't written the code to push the temperature data to the phone. So we'll do that next.
So next we're going to update the Arduino code in order to run the temperature sensor. So I'll go to the SunFounder website. SunFounder is where I bought the sensor from, and SunFounder provides an example sketch of how to run the temperature sensor. So I'm going to update our Arduino code using a bunch of the lines from this example sketch. I'm going to do it pretty quick because it would be pretty boring to watch. So this is OneWire is a library that's used to communicate with the temperature sensor. Dallas Temperature is a library that converts the digital information to Celsius, and there might be some other information coming from the sensor. Wire, I'm not sure what that does, but I think it's necessary. We need to change this value to 38. You might remember on my sketch of the wiring diagram, we plugged in the digital wire coming from the sensor to pin number 38 on the Arduino board. I'm going to add a little routine here to get the temperature from the sensor. Nothing mysterious here. V6 is, you might remember on the Blynk project, we set the temperature display pin to virtual pin 6. So that's why we have virtual pin 6 here. So this is a routine that causes the Arduino to get temperature from the temperature sensor, and then this command pushes the information to the Blynk project that we created a little while ago. I also have the temperature printing out on the serial monitor. In the setup, we need to make sure that the sensor starts running, and we need to create a timer to get the temperature. This is going to happen every 6 seconds. You can do it faster, but 6 seconds was sufficient for what I was trying to do. And now we are ready to write this code to the Arduino. Let's make sure it compiles. It compiles. Okay, let's write this to the Arduino.
Blinking. Good. All right. Now we'll go to our Blynk app and hit play. It's offline. Oh, there it is. Hey, there's our temperature. Let's see if the temperature changes. Yeah, temperature changes. So we are rocking and rolling. Ta-da! All done. We have Wi-Fi communication between the Arduino Mega and my phone using an ESP8266 Wi-Fi module. And we can turn light on and off too. All right, well that's it. I hope you're able to succeed and get this circuit to work, and good luck.